النهارده الفالنتاين فمفيش احسن من ماكس بلانك. My love for you is constant. Happy Valentine's Day.
احنا دلوقتي هنخش في برانش جديد من الفيزيكس غير اللي احنا بندرسه طول حياتنا. طول حياتنا بندرس ايه؟ فيزيكال فيزيكس. هنبتدي دلوقتي في المودرن فيزيكس او في الكوانتم فيزيكس. دي بقى ايه؟ مش ليها شويه حاجات كده وقوانين غريبه والعلماء بقى قعدوا يقولوا افتراضات ممكن تكون مستحيله بالنسبه للعقل انه يستوعبها، بس هنشوف كل الحاجات دي سوا. Next. And we will start by the difference between particles and waves. Particles must have mass. VS waves cannot have mass. Also, they occupy volume in space. In the other side, waves do not occupy volume in space, and we cannot see it with our naked eyes. Also, particles have momentum. And they may have a charge, such as the electrons that have a negative charge. Waves experience four different phenomena, such as reflection, refraction, interference, diffraction, as we studied in the first year. Reflection and refraction can occur to particles, but but can also occur to waves. But interference and diffraction are special for waves only. We will talk about the phenomena of radiation. Humans, like all humans, emit infrared radiation. And also we have some devices that sense the presence of humans using infrared radiation, as they emit some small heat, as our bodies have a low temperature. On the other hand, some bodies have high temperature, such as the sun, such as burning coal or fire. It emits infrared radiation in addition to visible light that appears in the form of orange or red light. Because of that, we can see the sun with its orange or yellow color. As we increase heat, the energy increases, and we will start to see more different colors moving from the red to the blue.
Between the intensity of the radiation and the wavelengths. When experiments try to make experiments to get the relationship between the intensity of the waves and the wavelengths, they get this graphs. It just full like directly proportional, then it gives an inverse proportion. They were confused because they didn't know why it gives a directly proportional. They know that wavelength is inversely proportional with the intensity. So there was scientists at that time confused because they know that intensity is directly proportional to energy, and the energy equal length constant minus F, which is frequency. And the frequency equals c, speed of light, over the wavelength. That means that the energy is inversely proportional to the wavelength, so the intensity is proportional to energy and inversely proportional to the wavelength. So they concluded that the graph will be like that. But they found by the experiment that the graph gives like that, and they don't know how to explain it. After that, we get
The difference between classic and modern, yes?
Yeah, that was a classic and modern vertex. After that, we get the scientist, which is Max Planck. He made a research paper about this phenomena, and he just published it. And again, after some explains this phenomena. We here have this part is for ultraviolet rays. Ultraviolet was here, and this is the visible light. And after that, this part is in the infrared rays. This ultraviolet high intensity, and this is the infrared rays. When Max Planck started to explain this phenomena, he said some explanation about the nature of light. First, we have that the light is not just act as a wave; it also sometimes act as a particle, and it is a quantum of energy called photons. What is photons? Photons is energy, which we have the energy level, it's energy level 1, and we have second energy level 2, and this is an electron. When an electron gets excited, it goes to the second energy level there,
Higher energy.
the higher energy level, and when it loses its excitation, it loses energy to get back to the lower energy level, so it emits an energy called photon, and that is what causes light. So he said that the light possesses of quantum of energy called photons. The energy of one photon will equal to Planck constant times Lf, which is frequency. When there are multiple, the light, in other words, not just one photon, many other lights, we will just add n, which will be the number of photons, if we want to calculate the energy of more than one photon. He also said that the energy of light is quantized. What does it mean? That means that if the light, if one photon is 10 joule, have energy 10 joule, that means that when it will increase, it will increase to 20, to 30, to 40. It will not be 11 or 15. This is not acceptable in the quantized theory of Max Planck. He also said that the intensity of light depends on number of photons, and that's what explains the graphs after, the graphs before, sorry, that we have here, the ultraviolet rays. The number of photons there was little for the ultraviolet, so it just was coming around. It was a wavelength. At that wavelength of the ultraviolet, there was no much photons, so it comes directly proportional because the photons just increased. After that, it comes to the visible light, which have large number of photons. So the intensity here is high till we reach the peak. We call it this wavelength peak because it is the highest one. After that, we have the infrared rays. The number of photons decreases till it reaches the infrared rays, and it just decreases like that. That was the explanation of the modern physics.
What can the color of any object? What can the color of any object?
How can we see?
How can
How can we see the color of the object? Okay.
Like light or one color of light. For instance, this pen reflects only the red light. The red light is my eye, so I can see the red light. So I can see.
Number one, the white light, the white body يعمل reflect all light color that falls on it. The black body يعمل absorb. إذا أنت كمان دلوقتي يعمل absorb من اللايت، ويعني هو جد إيه جد absorber، بعد كده بيعمل re-emit، وعشان كده بقول إن هو جود إيه؟ جود radiation يطلع إيه كل اللي فيه. فده اللي بنتكلم عنه النهارده.
any object that the color reflect specific color and rest light vision inside it as a rotation. For example, the modern car is black color, high degree of black, so it absorbs 99.96% of the light vision, so we can see it clearly in the room.
اي emit او radiate energy directly proportional مع السكوير اوف temperature او its temperature.
Radiate more radiation.
اوكي.
Powerful. We remove this radiation.
يبقى الباور ايكوال
Stefan.
Sigma. times epsilon A T power 4. Well, that's the way our session today. We will solve about this equation. Okay? Okay.
Then, as we can conclude from the previous explanation, that there's a relation between temperature and the temperature, radiation, and the wavelength. As the energy increases, we concluded that it is inversely proportional to the wavelength, and as the temperature increases, the energy increases. There are some changes that happen to this graph, the graph between the wavelength and the intensity. If we suppose that this is the graph for about 2000 for about 2000 Kelvin. If there's a graph with a high temperature, this graph will shift this way to the left, to this is the peak of the wavelength. Will shift to the left to this wavelength, and the intensity will be greater.
Yes.
This wavelength too, and this phenomenon is described by Ven's law. Ven's law, which is the delta P1 over delta P2 equal T temperature 1 over temperature 2 in Kelvin. There is a question. If we suppose that this is a blue star and this is a red star, which do you expect will have the greater energy? The blue star, because it has lower wavelength, and so it has a higher energy. This law opened the doors for astronomers and to measure the temperature of highly really distant stars from our place here. They can detect it from the wavelength of the stars, all the universe, their energy, and know expect and predict other things like the core and the heat. And yeah, it's really good for astronomers and astronomy.
Question 1. Which of the following statement is true? How black body radiation changes as the temperature of the radiation object increases? Who can solve? As we know that the temperature as the temperature is inversely proportional with the wavelength. So as the temperature increases, so the wavelength increase.
Okay.
This is wrong. This is wrong. Also, as we know that the intensity is inversely proportional with the wavelength, so, and directly proportional with the temperature. So the intensity also will increase.
This is wrong.